What is a unit vector? A unit vector is a vector that gives us information about another vector's direction without having impact on the magnitude. We use lambda to represent our unit vectors. So a unit vector is always going to have a magnitude of 1 multiplied by the magnitude of a force. It will give us our force vector. Since the unit vector always has a magnitude of 1, that means the summation of the square root of the sum of the squares is equal to 1, meaning that you're either going to have a full amount in one direction, for example, 1i or 1 in the x direction with 0 in the y and 0 in the z, 1 in the y direction or the j direction with 0 in the I and 0 in the k, 1 in the k direction with 0 in the I and 0 in the j, that's fully in the z axis. Or we can have unit vectors that are a combination of these. For example, we could have a unit vector that is halfway between our x and our y axis, but it is on our xy plane, equal parts x and y, or equal parts I and j, and this would be the unit vector for that function. We can calculate the unit vectors using two different methods. The first one is the direction cosines method, and the second one is calculating the unit vector using 2 points. For the direction cosines method, we're going to calculate the unit vector using the cosines of the angles between that vector and each of the axes. It's pretty uncommon to have all of these angles. Of course, we can find them in a lot of scenarios, but more often than not, we're going to be given 2 points that we can work with, or physical geometries that we can work with. We can find a unit vector using 2 different points, calculating the vector that connects them, the direction of the vector that connects them. First step is to calculate the displacement. So subtract one of the points from the other one of the points. The second step is to find the magnitude of that. So that's going to be your square root of the sum of the squares. And the last thing is to normalize, which that means we're going to divide our displacement vector by our magnitude vector. What might this look like? So our displacement vector, let's say we're working with the points A and B. Our displacement vector is going to be the difference between those 2 points. The magnitude of that displacement is going to be the square root of the sum of the squares. That's the square root of the x component squared plus the y component squared plus the z component squared. Once we take that displacement magnitude, we can divide our displacement vector by the displacement magnitude to get our unit vector. So what we're doing is we are saving the directional information while dividing out the magnitude, while getting rid of that amount information.